I have probably one of the most highly requested accessories for Starlink on the table in front of me. It's right here in this box. This is the new Starlink standard DC to DC power supply, and it's compatible with the Starlink standard dish like the one I have on the table in front of me. This allows you to run your Starlink dish directly off of DC, directly off of a battery without the need for an inverter. Now this is huge because people have been asking for this for years, basically ever since Starlink released their Roam service plan that allowed you to travel with your Starlink dish. So now finally we have a DC power option for the Starlink standard dish directly from Starlink. So in today's video, we're going to be taking a look at it, doing an unboxing, doing some testing to see how efficient it is versus running an inverter to power your Starlink dish. We're going to be diving into all that and more, so let's jump right in. All right, so the standard DC to DC power supply, that's what it's called. It's available from Starlink on their shop at shop.starlink.com. It was $110 when I purchased it. And you know, the pricing on it is actually pretty comparable to a lot of the third-party options that exist to be able to convert your Gen 3 standard dish to DC power. For example, this Amazon one that I purchased a while ago, it was $114 at the time that I purchased it. I'll put a link in the description below if you want to check out the current pricing. I think it's around $90 now. But what this is basically Starlink's version of what the third-party companies have already been doing, which is basically a DC step-up converter that allows you to power the Starlink standard dish directly off of DC. The $110 price tag of the Starlink unit is pretty comparable to other popular third-party options like the Trio flat mount DC converter, which is I think $90, and also the Dishy no AC, which is I think around $111 at the time of this video. I actually did a review on the Dishy no AC before this one was even available, so be sure to check out that video if you want to learn more about those third-party options. I think the only real downside compared to third-party options is that it's a little bit more cumbersome to use a third-party router with this setup because you have to retain the Starlink router in your setup, plugging your third-party router into one of the Ethernet ports. With the third-party options like the Dishy no AC, you can eliminate the Starlink router altogether because they include a PoE injector. That allows you to more easily use a third-party router, and it kind of simplifies your setup a little bit. But if you want to stick with the Starlink router, I would definitely recommend going this option and get the standard DC to DC converter from Starlink because that retains your Starlink warranty. If you ever have any issues, you can also contact tech support to troubleshoot this as well. So let's dive in and unbox this thing, see what's inside here. We have our typical regulatory notices paper, and then we have right on top here the actual DC to DC power supply unit. Let's take this sleeve off. Okay, so here is the DC power supply, and you'll notice it's very similar to the AC power brick that comes with every Starlink kit. It's actually the exact same enclosure, so the same size and everything. If you have one of those existing power supply mounts from Starlink, like the third-party offerings that you can find on Amazon, you will actually be able to replace your AC power brick with the DC one because it's the same size and everything. So you have the typical power plug for the router. This goes into your Starlink Gen 3 router, which provides all the power. And then on the other end, this is really the difference between the AC power supply and the DC power supply. In the DC power supply, you have an XT60 connector. And this accepts anywhere from 12 to 48 volts. So you'll be able to hook it up to your car, your RV, a portable power station, etc. We'll get back to this here in a second, but I wanted to finish the unboxing. So you have this little separator card. It's not instructions or anything, just a separator. And the last thing in the box is this included DC power cable. Now this is interesting because they have XT60 connectors that go, obviously plug into there, but it's the same connectors on both ends. This is about a 3 feet or 1 meter cable. And my guess is that they really included this so that you could plug one end into the DC power supply and then you could cut the other end off and splice it into whatever application that you see fit. So for example, if you have if you're putting this in your van and you have an existing DC fuse bank, you could cut this off, splice it right into a fuse circuit on your power supply, on your battery power supply. So I think that's why they included this. It's nice heavy duty cabling, but it does have the same XT60 connector on both ends. But now going back to the actual DC power supply, it's really nice that they put this XT60 connector on here because that allows you to buy third-party cables and adapters like the one I have here. So I picked this one up off of Amazon at the same time that I ordered this, because this I think is going to be a popular cable, because this allows you to go from the XT60 connector on the DC power supply, and it goes right into this familiar 12-volt car outlet. So this means you could plug this directly into your car's 12-volt outlet, or perhaps a 12-volt outlet on a portable power bank, and power the Starlink Gen 3 dish that way. So the specs on this, they're saying that it supports anywhere from 12 to 48 volts of DC input on the XT60 connector side, and it lists 30 amps, which is kind of interesting, and we'll touch more on that later, because in the setup of this video and the testing that I did yesterday, I kind of ran into some issues, and I'll talk a little bit more about that. But it asks for 12 to 48 volts, so it's going to be compatible with a wide variety of power systems and batteries. And the output on this is 56 volts at 3.57 amps. So that's around 200 watts. So this is capable of outputting about 200 watts to the standard dish. All right, so that's the standard DC to DC power supply, but let's put it to the test. Because the main reason why people are going to buy this is they have an off-grid situation. So maybe you have an off-grid cabin, or you have a vehicle or an RV or a van or something like that, where your primary power source is your battery system. And you could use an inverter and power the standard Starlink dish, no problem. However, many people don't like to use inverters because there's some inefficiencies introduced when you have to go from a DC to an AC, and then through the Starlink system, it goes back from AC back to DC to power the dish. So there's some inefficiencies there, and that actually uses up quite a bit of power that's actually just wasted in that conversion process. And I know what a lot of you are going to be thinking, which is, why wouldn't you just use the Starlink mini dish instead of the standard dish, which runs natively off of DC power? And I totally agree with you there. So the mini is really great for those mobile applications because it uses a lot less power and has a native DC input option. However, the Starlink standard dish has better performance overall. So the Wi-Fi router is much better. It's capable of higher peak download speeds, and generally it's just cheaper overall. So right now in the United States, the standard dish is $349, whereas the mini dish MSRP is at $599. And many people just already have a Gen 3 standard dish because they bought it before the mini came out, and they don't want to buy a whole nother dish just to be able to run off of DC. So this standard DC to DC power supply is a welcome addition to the Starlink accessories, because it allows you to use OEM parts to convert your Starlink standard dish to run off of DC. All right, so let's put this to the test. Let me set up my little testing environment here, and I'll show you how this hooks up, how this works, and we'll be testing the AC versus DC power consumption to see how much this can save by running it directly off the battery. So the first thing that we're going to measure is the AC power consumption. And what we're comparing here is using an inverter versus using directly to DC. So I'm using my Pecron E600 LFP power station as my inverter. So I've got, as you can see, my Starlink Gen 3 router. This is my home kit. The dish is up on my roof. So it's mounted in a place with no obstructions. I use it daily, so everything's all good there. But I have the router down here, and it's hooked up to the AC power supply, which is hooked up to the inverter output, AC output on my Pecron power supply. Now I have a couple different meters here. I have this kilowatt power meter hooked up on the output of the inverter, and then I'm also monitoring the output according to the Pecron. And I wanted to show you this because it's an important lesson to learn here about why people want to use DC power directly. So if you notice, the number on the screen, the watt reading here on the power meter, is always lower than on the Pecron reading itself. And the reason that is because the Pecron and most power stations calculate the inverter losses into your wattage output number. And this one right here is just calculating the wattage from the load itself. So if this one reads 45 or 46, this one might read a few watts higher. And that's because you're losing energy through the inverter process. Another thing that I wanted to point out real quick, on the Starlink app, as you can see, I'm online, but as you know, we have the power draw section of the Starlink app now, And this one is reading an average of about 42 watts over the last 15 minutes. And 42 watts is significantly lower than what we're getting from this watt meter right here. And that's because the reading on the app only takes into account the power used by the dish itself. It doesn't take into account power used by the router or any losses incurred when you go from AC to DC that goes into the router. The watt number is dancing around a lot, so it's hard to get an average, but the way I'm gonna run this test is I'm gonna watch it for about 10 minutes. I'm gonna make a reading every minute, write it down, and then calculate the average of the 10-minute power usage. And that'll give me my baseline number for the AC power consumption average over 10 minutes. And then I'll repeat the test, hooking up our new DC to DC power supply. Just repeat that same test, look at the output from the Pecron here, and we'll calculate an average as well and compare the two. I also forgot to mention that I am running a YouTube video playlist in the background on this connection. So I am simulating some throughput, as you can see on the graph here, during this testing period. So I'll be running that YouTube video playlist constantly during both of these tests to give some throughput. That doesn't seem to affect the power usage too much, but we want to simulate real world conditions here. All right, so it's been about 10 minutes of running this test and I've got a result here. So the AC power consumption average over the last 10 minutes using the inverter here on my Pecron power station, 66.1 watts is what the Starlink standard dish has been using. And that includes the losses from the inverter. So I took that reading from the display here. So now let's hook up the DC power supply and see if we can improve on that. So it's pretty simple really. All you have to do is basically replace your AC power supply with the DC version. So I'm gonna get rid of this and we'll get rid of the AC power brick completely. And we'll bring in what we're gonna use for the DC side of it. So here's our DC to DC converter. One end of it plugs into the Starlink router, just like that. And I'm gonna be using the cable that I got off of Amazon. I'll put the link in the description below. That plugs into the other end of the power supply. And then the 12-volt car adapter I'll plug into my power station here. And I'll turn it on. Got a red light, so that means we're powered on. Got a light on the router as well. So we'll check back in about 20 minutes. I'm gonna let it boot up and stabilize, and I'll check back in with you before I start the test. So it's been a few minutes, and it doesn't look like my Starlink is able to boot up on this DC to DC power supply. So if you notice on the display here, it's constantly reading between like 5 watts and 10 watts. It never ramps up above that. Typically with the Starlink standard, it'll ramp up above 100 watts on the initial boot up and then stabilize out. On the Starlink app, I'm not even getting any Wi-Fi connection at all. So the Wi-Fi radio of this thing is not even really able to fully boot up. I do have a light on the router, so it at least tells me that the router itself is getting power and is powering up. And that's also reflected here by the fact that it's using about 10 watts right now, but it's not actually completing its boot up cycle. So I have to wonder if A, if this cable is an issue, or B, if the Starlink Gen 3 DC to DC power supply just needs more watts than this is able to output. So the rating on this is 12 volts at 10 amps. And actually I just measured it and it's running about 13 volts. So I do have more than 120 watts available from here, but it's still not allowing the Starlink to boot up. So I'm gonna try another power station and a few other things. Okay, so I got an update for you. I did find a working solution. We'll talk about that in a second, but I wanted to kind of run through the troubleshooting that I did. So I couldn't get it to power up via this 12-volt outlet on this power station. So I thought, okay, let me try another one. Got this EcoFlow Rivet 2, and that one didn't work either. It never got over 10 watts. The router and the system would not complete the full boot up cycle. So I thought, okay, I know that I've got this working in my travel trailer right now with the Dishy no AC, so I wonder what the difference is. So I went out and grabbed, actually had this in storage just on a trickle charger. So I grabbed my 12-volt battery out of, that usually goes in my travel trailer, and I've got this little solar charge controller that kind of can be used as an interface and as a little voltmeter and an ammeter for this setup, and I hooked it up in this configuration. So I'm using the DC to DC cable that's included in this kit from Starlink. That's connected to the load output here, and then this battery is connected to the battery side of it. So I can see now that I'm getting normal power readings, 5 amps at 12 volts. So that's normal. The Starlink is booting up and working right now on this setup. So I thought maybe the DC to DC power supply here needs to see this cable connected in order to start up. So I tried it with, instead of the battery connected, I tried this cable here hooked up to the Pecron 12 volt outlet, and that didn't work either. So I don't think it's that it needs to see this cable. I think really what it is that the 120 or so watts that this is capable of is just not enough. And the Starlink router senses that and just will not allow the Starlink to boot up. Got an update for you. So I did hear back from Starlink support. They actually got back to me really quickly, which I was happy to see that their customer service has improved. But basically, they sent me some kind of confusing and conflicting information. When I first submitted the ticket and asked about the power requirements for the Starlink DC to DC power supply, they came back and had an odd answer that told me I just needed an inverter or a generator that had at least 500 watts of output. To which I responded, that doesn't make sense, because the whole point of this is to be able to use Starlink without an inverter. I got another customer service rep, I think somebody that knew more about this new product, that said, sorry about that. Actually, the power requirements are you need at least 20 volts at 5 amps, which is 100 watts. And that was also confusing, because that's the power requirement for the Mini, for the USB-C power supply. And that's what I told them. I said, that doesn't make any sense. This is supposed to run off of 12 to 48 volts. It says so on the spec sheet. And so that rep again apologized, saying that he was misunderstanding my question, and then came back with the final answer before they closed my ticket, which was that this requires 30 amps at 12 volts. So he was just kind of referencing the power requirements that are printed on the back of this and on the spec sheet on the website. So essentially what he's saying is that if you have a 12 volt supply, you need to be able to supply at least 30 amps of power to this DC to DC converter right here, which is kind of insane, because that's way too many watts. That's way more watts than the Starlink actually uses. Bottom line though, I think from what I've learned with this interaction is that be prepared to supply at least 200 watts to this. 200 watts is the maximum output for the output side of this at 56 volts. So I wasn't able to get it to work with 120 watts on either of these power stations. So keep that in mind if you're using it in a car or from a power station. I think if you're using it in an RV where you have a dedicated fuse block for your battery system, or you're using it at maybe higher voltage ranges, like you have a 24 or 48 volt system, you might be okay. But if you're gonna fuse this on your own power system, maybe go with like a 15 amp fuse if you're using 12 volts, because the 10 amps that I had here available just wasn't cutting it. It actually didn't turn on the Starlink at all. So with that all kind of figured out, I can still run this test. I'm gonna be running it the same way, letting it run for about 10 minutes and measuring the power that it's using every minute or so. I can't use the display on the Pecron, obviously, but I do have this little solar charger thing here that does have the capability to measure amps. So I know the battery's voltage and I know the amps that are coming out of it, so I'm gonna be able to calculate the amount of watts that it's using. And so I'll let it run for 10 minutes in this setup, and we'll measure and get an average watt usage for this setup and compare it to the AC result. All right, so the test here has been running for about 10 minutes. Like before, I'm running a YouTube stream in the background, and our average power consumption came out to be 64.1 watts average during that 10-minute period. If you do the math between the AC result, which is 66.1 watts, that is a 2 watt difference for a 3% difference total in between the two. So that's kind of around the same that we saw when I compared, the inverter reading on the Pecron versus the watt meter that I had hooked up to the AC output of the Pecron. So just a 3% difference there running it on an inverter versus directly off a DC. So not a huge significant amount. That's really just the difference between what an inverter loses versus a DC direct connection. Final thoughts on the Starlink standard DC to DC power supply. So I think it really comes down to what your situation is and what your expectations are. If you're somebody that you have an application where you don't have an inverter, then a DC power conversion is a requirement, because obviously you don't have the ability to plug the Starlink Gen 3 power supply into an AC wall outlet. If you do have an inverter though, it depends on if the power savings is worth it or not. So I measured about a 3% difference. 3% power savings is what you can expect if you're using your Starlink standard dish directly off a DC versus using an AC inverter. And that really boils down to the difference of inverters. So inverters are inherently inefficient. It can be anywhere from, like I measured about a 3% inefficiency versus upwards of 10% or 15%. Just depends on which inverter you have. And that really is your power savings by going directly to DC. It's also just a simplified setup in some cases. So it really depends on what you're trying to get out of it. I think overall we have to compare this to some of the third-party options though, because whether or not you want to run a DC conversion is a personal choice, but really in this review it comes down to comparing it to other options. Now there are cheaper options on Amazon. I'll link one in the description below, the one I showed in the beginning of this video. If you don't plan on using the Starlink router and you want to use a third-party router, I say go ahead and go with one of the third-party options like the Dishy No AC. That allows you to get rid of the Starlink router completely while also having a pretty reasonable price of just $111 or so, and you get a much more simplified package. But overall, I think my biggest disappointment with this product was my experience trying to use it with my Pecron power station. So it has a 12 volt, 10 amp, which is about 120 watt output, but I was not able to get it to work with this DC power supply for the Starlink standard dish. I was able to get it working directly off of a 12 volt battery, which didn't make a lot of sense to me. I'll have to investigate that further, but that just kind of goes to show you that your mileage may actually vary depending on what you're trying to power this from. Starlink support wasn't very helpful in trying to give me a minimum wattage specification. All they told me was that you need at least 30 amps at 12 volts, which is a lot of power for the Starlink standard dish, and I don't think many 12 volt applications, especially if you're going to be using a power station like the ones behind me, not a lot of those support that kind of output. If you're interested in the Starlink standard DC to DC power supply, check the links in the description below. I'll link to the shop page where you can find that on the Starlink website. And if you're interested in any of the other products that I featured in today's video, including the cable with the XT60 connector, that will also be in the description of the video. If you have any questions about this or any input as far as the issues that I had with the Pecron power station, let me know in the comments below. As always, thanks for watching. We'll see you in the next video.